I was always embarrassed that my name was Cornelis Adolf Gehrels. And so when I was young, I just went by Neil. I didn't even know how to spell Cornelis for a long time. And Adolf, ugh. I grew up in a family that was, my father's an astronomer. When I got to college, I thought, well, I really want to do something else just to be different. But I realized that after a while that this was really my passion and my biggest interest. And so I came back to studying physics and astronomy. And it's been a delight ever since then. When I was a young physicist, I was thinking only of being a theorist and following in the footsteps of Feynman and Gell-Mann. And that was my dream. Luckily, I stumbled into the laboratories of Robbie Vogt and Ed Stone, and really got hooked on space astrophysics. In 1998, I put together a team of scientists to propose a mission called SWIFT. And we proposed this mission to the NASA Explorer program, which has opportunities every couple of years. There were 40 proposals submitted. Each one is a pretty thick document. I still have the SWIFT proposal in my office. And we were lucky enough to be selected. It was launched in 2004, and it's been working splendidly since that time. Every time that SWIFT or Fermi detects a gamma ray burst, we're paged on our cell phones. And scientists get the page and they go running to their computers to see what the universe has sent us and what we can learn about the universe. And I was at a recent gamma ray burst conference when bursts went off, and you could see people in the audience slowly filtering out. And then at some point the speaker left. So, you know, this was an event that everybody wanted to look at. And we can use gamma ray burst as tracers to see how many supernovae were occurring in this early part of the universe and how many stars were being formed. We're also learning about the effects of gamma ray bursts on life in the universe. They're so intense that they affect and destroy the atmosphere on planets that are nearby. Luckily for us, this is an extremely rare process. And so the chance of that happening is infinitesimal. It's much less probable than an asteroid causing an extinction on the Earth in the current era. But if we go back several billion years ago, sort of in the middle age of the universe, the material is much closer together, and gamma ray bursts were a major force in preventing life from forming through much of the history of the universe.